weighs in at only 3 pounds and is 80% water.
It's a marvelous creation, the greatest creation in nature.
It's capable of computational miracles.
May 12, 1961.
Was a Friday.
We can't live without it.
As soon as I moved his hand, a lot of blood just started flowing from his head.
But it can also turn life into a waking nightmare.
I was at a point where I thought I was gonna die like this.
Could it hardwire people for crime? Can it unlock the secrets to sexual satisfaction? And find out what's so special about London cabbies? Find out everything you need to know about the brain.
Why can't sharks stop moving? Am I safer under a bridge or in my car? Will we ever transplant a human brain? What regulates the body's temperature? Makes us hot or cold-blooded? Are there more natural disasters now than ever before? Everything you need to know.
The human brain is truly amazing. Without it, our lungs would stop breathing, our heartbeats would falter, and our bodies couldn't move a muscle. But these 3 pounds of tissue do so much more than that. The brain is what creates language, dreams, and love. It's no wonder that this complex organ is also the body's most delicate. When your brain is broken, sometimes there's only one way to fix it. From the inside. This patient is about to have brain surgery, but the anesthetic is just a local.
Wake up now.
Hamilton, how are you?
Good. How's sleeping?
They call it awake brain surgery.
Having the patient awake during particular types of surgery is actually safer for the patient because it ensures that normal brain function is not impacted in a negative way.
Awake brain surgery is used to treat patients with medical disorders ranging from tumors to Parkinson's disease.
How did that feel? You feel a difference?
Yeah.
Are you enjoying it?
Well, I don't know about enjoying it, but...
The brain itself has no pain receptors. So the human experience of pain actually comes from receptors on our skin, in our tissues, for example, that allow us to feel pain from the environment.
Dylan Leha has epilepsy. His doctors are hoping to find the part of his brain that's causing him to have seizures and remove it surgically. A database of brain maps gives them a good idea of what part of the mind controls what functions. But every brain is unique. A scan of Dylan's brain, taken during a seizure, helps them zero in on the problem area. But the picture is not precise enough for the surgeons.
My particular surgery is really close to my memory, and so they're going to have to pay real close attention to that.
The surgeons have to make sure they cut out the epileptic tissue in Dylan's brain and not his memory or his ability to talk. The only way to know for sure is to get in there and poke around. With Dylan's brain exposed, doctors ask him to name objects on slides. They're zapping parts of his brain with electrical current to momentarily knock out their functions. It helps them identify critical areas and spare them the knife.
Can you tell me what you see?
Right now, Dylan is physically unable to speak. That means they found his speech function and need to leave that area alone. When the probe is removed from that spot, he is able to speak again. After several hours, the doctors remove the area causing the epileptic seizures, leaving the rest intact. Dylan's recovery took several months, but he is now seizure-free, one sign of the amazing adaptability of the brain. So just what is the brain, and how does it work? Let's take a look at the nuts and bolts inside your head. Most of the basic functions are handled here, where the brain attaches to the spinal cord. It's called the brainstem and is responsible for heart rate, reflexes, and digestion. Just above that is the cerebellum. It's the part of the brain that makes it possible for you to walk, run, and jump without constantly falling over. Capping the whole thing off is the cerebral cortex. It makes up 85% of the human brain and is the section that really puts it together. Memory, vision, and thought processes happen here. It's also the place where the first stirrings of passion take place. What's our greatest sex organ? Don't look down, look up. Our mightiest member is the brain. It governs who we want, what we want, and a whole lot more.
He's tall, and I like that.
I think he's got a great body.
I am always admiring her parents' work.
Lying deep within our brain is something called the pleasure center. Brain cells in this region start firing according to personalized formulas for what each of us finds sexy. Scientists are zeroing in on what attraction looks like in the brain.
We looked at what's happening in the brain when we look at beautiful faces. We've done previous research looking at how we recognize faces. We know that there's particular regions, it's called the fusiform face area, in the back of the brain that recognize faces. It's something else going on when we look at beauty. We're finding a whole separate circuitry, and this circuitry has to do with reward. It's the same circuitry that you'll see light up when someone feels the rush of cocaine, or if they're want a lot of money.
But just because sparks are flying doesn't mean things are going to get hot, especially in the bedroom. For men, it's all about blood flow, and little blue pills like Viagra usually help. But for women, the secret to sexual satisfaction may lie in the brain. 1 in 3 women fail to reach orgasm on a regular basis. Now neuroscientists are coming to the rescue. They're looking at what happens to a woman's brain during masturbation and intercourse. This is an MRI brain scan of a woman at the peak of pleasure.
Almost all parts of the brain become activated. This is a big surprise to us. Nobody's been able to see the brain of women in orgasm previously.
Armed with new information, researchers are developing something called neurobiofeedback. Orgasmically challenged women can see what their brains look like when stimulated to near climax, in hopes of going all the way.
When there are spontaneous changes in brain activity, we will tell the person that was moving in the right direction. So whatever you did, do it again and do it more strongly. I think it's possible that in the future, a person in the scanner could look at his or her own brain activity and voluntarily change its activity and thereby experience an orgasm when it wasn't possible before.
Up next, why does this man's brain let him see something you can't? And later, how could anyone survive this? They have dazzling computational skills, virtuoso artistic talents, and encyclopedic memories. They are savants, and their gifts could be the key to unlocking the true power of the human brain. Kim Peek was the inspiration behind Rain Man, the film starring Dustin Hoffman and Tom Cruise. Kim can't tie his own shoes, but he can read a dozen books a day, and he has a photographic memory.
He reads a page that you and I would read in 3 minutes approximately. It takes him about 8 to 10 seconds. He reads the left page of the left eye, right page of the right eye, and remembers about 98% of it.
Need an encyclopedia? Just ask him.
When did Schubert live?
1797, 1828.
If Winston Churchill was alive today, how old would he be?
130.
Kim can also do mental acrobatics with dates. He can give the day of the week for any date going back hundreds of years. For instance, August 4th, 1902.
It was a Monday.
May 12th, 1961.
Was a Friday.
He also has a fully functioning sense of humor.
Well, what was Lincoln's Gettysburg Address?
227 Northwest Brent Street, but he only stayed there overnight.
So what's so special about Kim Peek's brain? An MRI scan reveals Kim has no corpus callosum, the structure that connects the left and right sides of the brain. Most savants have unusual brain scans. Mostly, they show some damage to the left brain. One of the results of this trait seems to be total recall memory.
Phenomenal memory seems to be a hallmark of savants. They have a kind of literal memory. They see all the parts of the picture without understanding what the picture is.
British savant Stephen Wiltshire uses his phenomenal memory in a different way. After seeing London's Houses of Parliament for only a few minutes, Stephen can reproduce it precisely on paper, down to the exact architectural proportions and number of windows.
Done it now. It's finished.
Scientists believe the right brain partially takes over the left brain in savants. They tend to struggle socially and verbally, a left brain trait. But their right brains are able to find patterns and systems in almost anything. Daniel Tammet sees numbers in a way most of us could never imagine.
I experience numbers in a very visual way, using colours, texture, shape and form. Sequences of numbers form landscapes in my mind.
A researcher armed with a calculator that Daniel can't see asks him to divide 13 by 97.
0.1340206. That's as far as my calculator goes. Brilliant. 185.
567.
You're carrying on.
I'm carrying on. Do you want me to stop or?
How many points can you do it to?
100. Nearly 100.
Savants are extremely rare. There are only about 50 savants like Daniel in the world today. But researchers in Australia recently tried turning ordinary Joes into wonderkins. They used a magnetic probe to temporarily knock out a part of the left brain called the frontal lobe. They then asked them to match days to dates and do some complicated math. The experiment worked. The volunteers became momentarily smarter. Although they were still no match for savants, we may be one step closer to discovering the full potential of our brains. What if you could just take a pill and get instantly smarter? Maybe you can. Here are a few drugs with unusual side effects. Donepezil, a prescription drug for Alzheimer's disease, seems to give healthy people supercharged mental abilities. Modafinil, which is traditionally used for sleep disorders, can improve concentration. And Ritalin, normally used to calm hyperactive kids, turns out to actually speed up the function of non-ADD brains. Civilians are not the only people interested in gaining a mental edge. A drug codenamed CX-717 is one of the Pentagon's newest weapons. It's designed to keep soldiers awake and alert for up to 4 days at a time. Good brains might become better brains. But what about bad brains? Dr. Adrian Rain, a leading authority on antisocial behavior, has spent his career trying to get inside the criminal mind. Literally. He says criminals actually have different brains from the rest of us. He used MRIs to study the brains of pathological liars.
Lying is very complex. We have to suppress our emotions when we lie. We don't want to appear nervous. We have to think about what the other person knows, what they don't know, what will be convincing to them.
Dr. Rain discovered that liars' brains are different from those of honest folks. The frontal cortex is made up of two basic types of brain cell, white matter and gray matter.
The gray matter in the brain is the neurons, basically the computers that do the computation. The white matter, in contrast, are the connections between the neurons. Essentially, the gray matter processes information, the white matter transmits the information from one brain region to another brain region.
When people lie, lots of brain regions light up at the same time, meaning the white matter is probably very busy. What do good liars have? More white matter.
What we found is that there's a 23% increase in white matter in liars compared to the normal controls. That's really quite substantial.
Before you go bragging about having a small brain, Dr. Rain has also found that lifelong criminals had 11% less gray matter in a key brain area.
We found that the murderers had much poorer functioning in the prefrontal cortex. It's a part of the brain that's involved in controlling and regulating the deeper centers in the brain, which give rise to aggressive feelings. If you lack good frontal functioning, you're more likely to lack control over your emotions.
Some people may be hardwired for crime, and neuroscientists may one day track them down long before detectives. Up next, At War with Your Own Brain.
I just slide my foot on every crack.
Later, what's wrong with this dog?
Everything you need to know.
Every 21 seconds, someone in the U.S. suffers a traumatic brain injury. 52,000 die from their injuries each year. Others are very lucky, like Maryland State Trooper Ben Young. Young was at the scene of a jackknife truck. He and another trooper stood about 20 feet away as the tow truck operator hooked up the vehicles. Suddenly, the weight of the truck snapped the weld on a hook. The hook shot through the air towards Officer Young and hit him just above the right eye. As the other state trooper radioed for a medevac helicopter, Young lay on the ground bleeding to death.
Patient comes in, we've got a suspicion of serious brain injury. They're not conscious, they've seized, they have some significant neurologic dysfunction. And we know that if we don't get the oxygen to the brain, even if we hit everything else perfectly, they do very poorly neurologically.
The force of the flying hook sent a chip of Young's skull into his frontal lobe.
Medics telling you, oh, things are going to be okay. The next thing, things aren't okay again, and we have a trooper that's not breathing.
I was very scared, very scared. Now I've got a trooper that, is wearing the same uniform I'm wearing, and is, in all aspects, is dying on me.
Ben's odds of survival were slim. His chances of a full recovery were almost nil.
For a trooper, our primary concern was memory, cognition, abstract thinking, speed of decision making. We were concerned that this could affect him for life.
During an 18-hour operation, Dr. Bijan Arabi sewed up the tear in Young's brain and repaired his skull with small titanium plates and screws. 1 week later, the bone began to heal. The odds looked good that Young would pull through, but it was still too early to know about any permanent brain damage. For decades, scientists believed that brain cells did not regenerate during healing. Ben Young helped prove them wrong. Some cells, including those in the frontal cortex where Ben was injured, do have this ability. After 5 months, Ben Young's life was back on track. He returned to full duty on the police force.
I think about how lucky that I got. If it was 2 inches higher, it would have just completely missed me. If it had been a half an inch lower, it would have hit me in the eye and blinded me. Half an inch another direction, it could have killed me.
The brain is by far the most complex organ in the human body. But even as amazing as it is, things can go wrong. That's what happened to Chris Duran when he was just 13 years old. Bacteria from strep throat spread to his brain and caused swelling in his basal ganglia, an area that controls learning and motor skills. Somehow, wires got crossed, and Chris began a battle against irrational fears for control of his body. The result was obsessive-compulsive disorder, commonly referred to as OCD. OCD manifests itself in a life full of never-ending rituals. For Chris, something as simple as walking home from school would take hours.
I had to slide my foot on every crack.
And he'd be doing this maybe 2.5 hours a day after school. So we get out at 3:30, so he'd be here till about 6.
Until it felt right, I would continue to do it over and over. After walking through this path, it would take me a good 2 hours. When I would take a test, even numbers were good numbers. I thought if I was to use an even number, I would be safe. I knew the answer. I mean, I would know it. But I mean, it was so strong that the even numbers like 2 and 4, I thought those had to be what I had to put down, because if I didn't, that I would choke.
Sports were totally out of the question for this once active teen.
When he had to quit basketball, that was the hardest thing, because he came to me and he said, "Mom," he said, "I wanted to cry." He said, "but I knew I couldn't do it."
I was at a point where I thought that I was going to be like this for the rest of my life. I thought that I was going to die like this. I didn't want to live no more.
Therapist helped Chris take back control of his life by forcing him to confront his obsessive habits head on. They stopped his foot sliding by repeatedly placing the teen on sidewalks until his brain learned to overcome its own illogical fears. Chris was fortunate. He got help early. On average, sufferers of OCD wait 17 years before seeking treatment. OCD is closely related to another brain disorder, Tourette's syndrome. Like OCD, Tourette's is located in the basal ganglia. The wiring of the brain mixes erratic signals in with normal ones. That causes involuntary tics such as eye blinking, body twitching, grunting, mimicking, and swearing. Sufferers describe the condition as being in a 24-hour-a-day pressure cooker. The tics alleviate the perceived stress, but soon it begins to build all over again. Medication can diminish the symptoms, although they sometimes naturally decrease with age. In even rarer cases, the condition actually worsens. That's what happened to Jeff Madovic.
Many days there's nothing I can do. I have to have drinks poured for me. I have to be fed, have to be groomed. And that stinks.
Holding a job to support his family became impossible. In 2004, he convinced doctors at University Hospital of Cleveland to perform an experimental procedure called deep brain stimulation. Electrodes placed into the brain help override uncontrolled movement. 2 pacemakers implanted in the chest keep the process working continuously. The results were almost instantaneous. Jeff went from averaging a tick per second to having none at all.
I've never experienced not having the compulsion to tick. And I mentioned to you before, I feel like I'm waiting for something to happen, but it just doesn't come.
The procedure Jeff underwent isn't suitable for all sufferers of Tourette's syndrome and carries the risk of paralysis and even death. But it's a huge step towards understanding the mystifying condition and what it can tell us about our brains. Up next, no pain, no brain? And later, could this be the next Top Gun? Why would someone in their right mind choose to take a kick in the groin? Or chew a shard of glass? The answer is mind control. In some remarkable individuals, the brain helps the body perform amazing feats, like blocking the sensation of extreme pain, or like these monks, generating intense body heat in near freezing temperatures. For decades, Dr. Herbert Benson of the Harvard Mind-Body Medical Institute has studied Tibetan monks during their meditation practice of Tummo, the yoga of inner heat. Incredibly, it only takes 2 hours for these monks to dry bed sheets soaked in cold water using only the power of their minds.
These monks, astoundingly, in simple meditation, could increase their temperature enough to get the sheets steaming and dry the sheets. You and I would go into uncontrollable shivering and perhaps even die.
Somehow, the monks managed to shift warm blood from their body's core out to the skin, using just the power of their minds. As the monks breathe, they picture the air as a kind of energy, a flame or fire coming through their chest. This man doesn't have to imagine fire coming out of his body. Tim Cridlin, aka Zamora the Torture King, can handle anything that burns, cuts, stings, or slices. Tim claims he's trained his mind to simply ignore pain.
Pain is a learned response, and being a learned response, it can also be unlearned.
To prove his mastery, the Torture King has agreed to be squeezed against an upright bed of nails and see how much pressure he can withstand. Paramedics monitor his brain activity and vital signs. Zamora claims he uses a meditative state to refocus the pain away from his brain as his body's being compressed against the spikes. The technique sounds far-fetched, but Zamora somehow manages to withstand an astounding 1,200 pounds before stopping the experiment. That's the equivalent of a small car.
You're gonna cast out the squeeze, getting the squeeze. It wasn't the nail.
Zamora hadn't succumbed to pain. He was suffering from asphyxiation. The air was literally being squeezed out of his lungs. His vital signs back up that claim, as they show no significant changes. Just imagine, if we could all tap into the mysterious power of the mind, we'd never need aspirin again.
If I couldn't do it, you'd have to just lock me up and throw away the key. I can't live without it. Definitely the best legal high out there.
Definitely better than sex.
It's just sick. I love it.
Adrenaline junkies. Addicted to speed, risk, and the unknown. Things most of us do our best to avoid. So what makes some of us thrill seekers? It all starts in a region of the brain called the hypothalamus, the master switchboard for excitement and stress. When stimulated, the hypothalamus sends neurotransmitters to the adrenal glands, kicking off a surge of adrenaline into the bloodstream. But what makes adrenaline feel good to speed freaks? It's hard to study an adrenaline-soaked brain at 300 miles an hour. But you don't have to. Just wait for July 4th.
People love fireworks not only because of all the stimulation, but from a psychological standpoint, there is what's called controlled fear.
That fear means adrenaline. To see what does happen to the brain, we hooked up a spectator at a fireworks show to a device that monitors brainwaves. Here's the readout when watching a dark sky. Here it is watching a few shells burst. And here is a fireworks finale. But this revolutionary brain mapping device can also create a visual map of brain activity to show exactly which parts of the brain are lighting up. During the intense finale, the activity shifted dramatically to the subject's right frontal lobe. the part of the brain that responds to pleasure and emotion.
When you look at the topography of the brain, what you see is that there was massive stimulation going on.
The adrenaline spike actually evoked a kind of trance state.
The individual's brain became completely stimulated, and he became completely absorbed.
I forgot that I was even hooked up. I was just so amazed.
No wonder thrill seekers aren't scared out of their wits. They probably don't even realize where they are. Not everyone reacts to stimulation the same way. 1 in every 2,000 Americans has narcolepsy, a brain disorder that causes the sufferer to fall asleep at the drop of a hat. It's very rare in animals, but check out Skeeter. Excitement puts him right out. What gets Skeeter most excited is food. Initially, that was all that triggered his attacks, but things have gotten worse, and now any excitement knocks him out. Maybe narcolepsy is the origin of the expression, "let sleeping dogs lie." Regardless, Skeeter's condition is good news for the mailman. He's greeted with a snore, not a bark. Here's one narcolepsy remedy that's definitely not FDA approved. Americans spend more on cocaine than all other illegal drugs combined. Want to know what it really does in their brains? Like other illegal drugs, cocaine swamps the brain with dopamine, a neurotransmitter responsible for pleasure. But unlike most other drugs, cocaine actually inhibits the way the brain gets rid of dopamine, so the high is even greater. Over time, an addict's brain physically changes and stops releasing dopamine altogether, except when the narcotic is present. The result? Everyday things that once gave a person pleasure no longer do. This is a scan of a normal brain. The healthy dopamine areas are in red. This is the brain of a cocaine addict. The dopamine areas are virtually gone. For this person, only another hit of cocaine will bring back the dopamine. Up next, calling all blackjack fans. This guy's the ultimate card counter. Later, 8 legs, and each one with a mind of its own. The human brain's remarkable memory separates us from the rest of the animal kingdom. As smart as we are, though, we can't remember everything. Short-term memories last about 30 seconds. They pass into long-term memory if they are particularly significant or by repetition. But imagine living life forgetting one moment to the next. This is reality for Trish McCosker. Just remembering where she's sitting in a restaurant is a struggle.
So many times I get up and I'll just nonchalantly leave and go to the bathroom, and I won't make a mental note of where I was sitting. Because if I've only met them once or twice and I'm on like the first date, I might not even remember the person. And that's mortifying. It's very scary.
A childhood virus left Trish in a coma. The oxygen deprivation damaged her temporal lobe, the part of the brain responsible for short-term memory. To make it through each day, she must constantly refer to a book that retains key information about her life. McCosker does actually remember a small percentage of new memories, but she could never do this. Meet Scott Hagwood, 4-time winner of the Memory Championships. In this test, Scott is given 1 minute to study the shuffled cards. After handing over the deck, Scott's given another and asked to order it in the identical sequence as the first one.
2 of spades, 3 of diamonds.
The 2 stacks match, the sign of a memory champion. Incredibly, Scott Hagwood had a horrible memory until he began studying how the brain remembers. He transformed himself from an average Joe to a brainiac. MRI studies of Scott's brain show that he can access his memory bank without activating other areas of the brain that would normally interfere.
What this is telling us is that you're using these areas of your brain much more efficiently.
He maintains that he's no different than anyone else. He's merely mastered a basic technique to help him remember and recall more easily.
When I'll use kind of a journey method, and what I'll do is when I look at the word, I'll try to find some kind of visualization.
Scott associates memory with mental images. Names and faces are no problem, but where he really shines is in memorizing long number sequences. Next, Scott is asked to memorize a random bank of 160 numbers. That's like trying to remember 16 different 10-digit phone numbers after seeing them just once. In 7 minutes, he's ready to recite the list in exact order.
9, 4, 2, 1, 3, 8, 6, 7, 3, 5, 2, 4, 8. The last 4 should be 7, 3, 2, 0.
Whether you have Scott's extraordinary powers of memory or just average recall, all memory is the result of neurotransmitters making chemical and physical changes in the cerebral cortex.
Memory is not just a fixed entity that gets stored and stayed there and waiting to be reproduced, but rather our memories can be transformed or changed by new experiences that we have.
These changes create memory pathways that let us store and retrieve information. And like Scott, we all use some kind of association, images, sounds, other memories to help us remember. Ever wished you had a bigger and better brain? Becoming a London cab driver might do the trick. Scientists at University College in London scanned the heads of cab drivers and found that their brains actually get larger and more efficient the longer they're on the job. The growth occurred in a part of the brain called the hippocampus, where navigational memory is stored. The revolutionary study was the first to prove that the mind can undergo positive structural changes.
You can actually train the brain to function better. It's just like an athlete. To stay in form, you gotta work out your brain to keep the brain in shape.
The increase may be due to the massive amount of street memorization the drivers do to complete their rigorous training. London cabbies must go through a tough 3-year training program called the Knowledge. They've got to know 400 different routes to graduate. All this has sparked the interest of scientists around the world. They're researching if similar training programs might help rehabilitate people with brain damage. Up next. Sure, we know more than ever about the brain, but are we getting smarter? Every animal needs an edge to survive. Some have powerful claws, others razor-sharp teeth. For humans, it's our brain. Millions of years of evolution have brought us a long way. Man is smarter than ape. Who's smarter than shark? But just because man's ancestors crawled out of the ocean doesn't mean they left behind a bunch of dummies. Would you have ever guessed that the octopus is the world's most intelligent invertebrate? Or that most of their brains are located in their tentacles? To find out just how smart they are, scientists put an octopus to the test. They rewarded this octopus with a tasty prawn after he figured out that a door with a cross on it hid the snack. Then the scientist added 2 extra doors, each marked with a different shape. Can the octopus recognize the shape of a cross? It can. The octopus remembered cross means supper. Now for something really tricky. Navigate an entire maze to find the shrimpy treat. Over several weeks, vertical walls and tubes were added to the maze. But even as the course became more complicated, the octopus made it to the shrimp faster and faster, proving that even a mollusk with legs for brains possesses the power of deduction. Rats are good at mazes too, but their brains are no match for humans, right? Well, biomedical engineers from the University of Florida found a way to make rat brains do something most people couldn't even dream of. Fly an F-22 fighter jet. They collected 25,000 neurons from a single rat embryo. They put them in a petri dish filled with liquid nutrient and watched them sprout nerve fibers. Before long, the tiny cells began to connect and communicate to form a mini brain. To test its IQ, they wired it up to some electrodes and put it inside an F-22 simulator. The idea was to see if the neurons could keep the plane in level flight, rather than to send it into a tailspin. It sounds like a tough job, but the most basic circuits deep in the human brain actually do a similar thing. They keep our limbs from flailing uncontrollably. Scientists handed over the controls mid-flight and, amazingly, when the jet pitched too far left, the brain sent back messages that leveled it. There's potential in all neurons. So what's the limit of human intelligence?
The human brain has been in its current configuration for about 100,000 years. It's a marvelous creation, the greatest creation in nature.
But are we finished? Have we hit our peak? There's new data that suggests our genes are still evolving, making our brains bigger and smarter. Humans have about 30,000 genes, the basic units that make up our DNA and define every physical component of our bodies. 2 genes in particular, microcephalin and ASPM, have been tied to intelligence. The first appearance of microcephalin in humans is believed to have coincided with the emergence of art, music, and tool-making 37,000 years ago, while ASPM is thought to have arisen 6,000 years ago, when language, agriculture, and cities were developed. To find out if more of us are getting smarter, scientists scan DNA samples from thousands of people to search for these smart genes. They found that there's been a dramatic increase in the percentage of people that carry them. It's taken 37,000 years, but 70% of all people now carry the microcephalin gene, and the ASPM gene has now spread to 30% of us. Researchers say it's the competition to stay afloat in our dog-eat-dog world that's causing this dramatic evolutionary change. In other words, survival of the fittest. The genes that give individuals a competitive edge stick around and spread among a population.
Nature doesn't give us anything unless there's a need for it. We use everything.
The bottom line, though it's slower than most of us would like, we are getting smarter. And finally, 5 brainiac facts bubbling up at the water cooler. The best way to have brain surgery is wide awake. One day, doctors could zap your brain so that you know as much as Rain Man. The brains of some violent offenders may actually be hardwired for crime. Want a bigger memory gland? Memorize street maps like a London cabbie and watch it grow. And you'll never need a clothes dryer if you've got the mind over matter power of a Tibetan monk.